Hi everyone, and welcome back to this series of videos about the Plutus Pioneer program, and in this case it's going to be about smart contracts being executed on Alonzo Blue. My name is Giovanni, also known as CryptoJoe101 on Twitter, and today I'm going to be doing my, with a little bit of delay, I'm going to be doing my homeworks for the testing of the Alonzo Blue network. So last week I was on holidays with the family, so my fellow colleagues went ahead and did the initial bashing of the testing of the first smart contracts script into the Alonzo Blue network. That is the very first, for those of you who don't know, that is the very first public testnet of Cardano where it is possible to run smart contracts. So last week, after the week before, we initialized the hard fork combinator, and the first few scripts were executed by the IOHK and IOG. It is now our turn to start pioneers and stakeable operators to start to mess with the network. So here is the website with the exercise and instructions on how to do them. I will add the link to this repository that is public into the description of the video, so you can access and take a look yourself. And I will show you a first interaction, a first execution of smart contracts. I also would like to remind you that I am running a stake pool into Alonzo Blue, and there is a public accessible Grafana dashboard where you can see the performances and everything that is happening on the stake pool. You can see the tip, the number of transactions processed, time at the end of the epoch, and a few other things. You should know that something different that is happening on the Alonzo Blue testnet is that every epoch is about 2 hours and not the usual 5 days. I guess this is to speed up the time and have more things happening at the same time. You can see my pool is minting blocks, no problem. Anyway, let's go back to the exercise. What is this exercise about? So the smart contract with which we're going to interact is extremely simple. And for those of you that have experience into smart contracts on Cardano, and if any of you is a Plutus pioneer, it could be of interest to you knowing that basically the smart contracts has a validation script that always returns true. So there is no way of breaking it, and there is no way that you will be denied the transaction. And this is a very simple smart contract where we can put money and then we can try to withdraw money, our funds. We're just talking about ADA. Of course, ADA in this public testnet, not real ADA of mainnet. The tricky bit on this is that those funds are protected, double quotes open close, by a kind of a password, a numeric password. And so that this is going to be given in form of datum, and then we have to specify this secret when we are putting the money into the script and when we are collecting money into the script, so that other people cannot withdraw them. This is not really secure, and this is just a test exercise because you could brute force the numbers out and basically collect all the numbers of all the other people. I've tried this very briefly, but it's so large the number of integral, natural numbers, and it takes too long, but this is definitely doable because this test can be done off channel. But anyway, for those of you that don't know that, I just would like to remind you that on the blockchain there is only the hash of the validation script. There is not actual the code of the smart contract. So whenever we're going to be saying in a minute is just basically a compressed representation of what the smart contract does. So the objective of these exercises are literally split into 2 sub-exercises. The first one is, I just forget the generation of the keys because I already have done that and it's part of an old stuff. And the first thing is to basically deposit some money into the Plutus script, some ADA, and then the next thing is to get those transactions back. So I have already the scripts somewhere prepared, the exercise is prepared, but I'm gonna be walking you through the steps. So the first thing that we want to do is we switch into the console, and here on the top there is the console that is interacting with the node. Here are the logs of the Cardano node running Alonzo Blue, and here there is some other test stuff that I was doing. So the first thing that I want to do is to check the funds that we have in this payment address. So what I can do is Cardano CLI query UTXO address, and then I can cut the payment address straight away into this one and check how much fund I have. So the first thing, if you're familiar with the CLI, you can see that there is already something different, and there is an extra, beside the UTXOs, there is also, and the amounts, there is also this TX out datum hash known. It means that there is no additional information saved into this UTXO. If you're familiar again with the Plutus Pioneer program and with the smart contracts, you know that you can save some information in the shape of a datum into a UTXO. In this case, of course, because this is all brand new stuff, there is nothing. We will need loads of ADA. Here there are 5,000 ADA, I guess. And we need them. Sorry, let me check the zeros. 3, 6, 9. We need this because we have to pay extremely high fees to run the smart contract, but this is all good and is done by intention and purpose because it's all a test thing. So what we have to do, if we go back to the documentation, is to basically, knowing that a smart contract is nothing else than an address on the what's it called, on the blockchain, what we have to do is to first of all find this address, and then what we have to do is execute the payments against this address so that we can persist the ADA into it. And this is very simple, and it's already explained into the documentation that you can check yourself, but the Plutus script is already been executed. If you want to take a quick look at it. Oh, sorry, the link is broken. I have to inform them. Anyway, is this the same thing? Yes, this is broken too. But we can find the body. I've actually downloaded this from somewhere else. Where did I take them from? I must have downloaded this from somewhere, I think. All right. Anyway, I downloaded this from somewhere else. I can't remember. And I have this untyped always succeed TX in Plutus here already. That is cut untyped. And this is basically the hash of the script. So I can actually execute this line that says, in order to create a transaction output hash in the script, in order to look, we must have a datum hash, and we have we have to find the hash of the script, and this is gonna basically then generate the address. So if I take this and I execute it, we will see basically an address, and we will have to without the root. So if we now do Cardano CLI query UTXO -- address testnet magic 5, we can see that there is already a lot of stuff going on here. You can see that there are a few people that have, lots of people that have persisted their own stuff, and you can see also that there is something funny going on here, and I'll explain this one better. But I can tell you that this one are lost money and this one are not. Let's see why. So in order to lock the data, the ADA, you also have to specify that password I was telling to you about just a few minutes ago. If you don't specify it, the script will still accept the money, but you will not be able to unlock them after. So, and this is exactly what's happening here. So the datum, that is the password, the numeric password, was not specified at the beginning, and so now there is no way of retrieving this. Of course, a good smart contract developer will prevent this from happening. And whenever a payment is made, the datum is also specified. But this is something to bear in mind. As otherwise ADA will be lost forever in this address. On the contrary, if the execution of smart contract was correct, you will see that the amount of loveless is here alongside some additional information, and this is basically the hash, a special hash. Actually, it's the CBOR representation of the numeric value that is also a hashed value. So all good so far. What we have to do now is to basically build the transaction. I have some steps already pre-prepared, so I'm gonna actually take them now and show the script. So let me increase a little bit. View, appearance, presentation mode. Great. So here this is the payment that we have to execute. There is a lot going on, but we can break this one down in a few simple steps. So what we have to specify is the first of all is the era. We're in the Alonzo Era, and then we have to specify input and output. So first of all, we're going to be using this number as our password, and then as it is specified into the documentation, I will not switch back and forth so that I will not give you guys a headache. I will have to run this command. Of course, I can script this one straight away into here, and this is basically the volume on the data mash that we are putting into the transaction. And then what we are doing, we also have to specify basically the payment address, and we have just literally done this one like 1 second ago, and how much money do we want to put in this one. Now, I've done these tests earlier on, so these fields are pre-populated. I will show you how to find those values in just 1 minute. Then we have to find the fee, and then this value here was called the TTL, time to leave, and now is being called invalid hereafter. That is more explicit. So this transaction can be submitted not later than this slot. So fair enough. Let's replace those values with the actual one. So the first thing that we have to see is the UTXO of my wallet, where we were gonna get the fund. So let's switch into this one, and then let's get again the UTXO I was talking to you about. So this is my test payment address, and the testnet magic is 5. So we're going to be using this datum hash. This UTXO. So you can see the transaction hash is this one, and the transaction height is 0. EX is 0. So we're going to be putting this one here, and then we're going to be putting 0 here. And the next thing that we have to take is the amount. Now we have to balance this transaction, and we have to decide how much money we're going to put into the script and how much money we have to spend as fees. So let's go back into this one. We decide that first of all, I'm going to save into this exp here so that I can make the calculation. I decided that I want to put 1000 ADA into the script. Just double check, and then this is the password, and then the fee. We're going to calculate the fee in 1 second, and then the slot. So let's use the calculate min fee. I'm just gonna copy and paste this one, but I'm gonna explain very briefly the fields. The testnet magic is because we are running on a testnet. This is the protocol parameters, where basically there are all the information about the blockchain, like min fee, min spend, and all those kind of things. Then we have one transaction in and two transaction out. Transaction in is where we are getting the money. Transaction out count is where the money are going. Because there is a change, so we're of the 5,000 ADA we're sending only 1,000 to the script. The other 4,000 it goes back into the wallet. In fact, this one is in out address. Actually, yes, I have to fix this one because there is one thing missing. So the transaction out count is actually, yeah, no, it's still 2. witness count is 1 because there is only one signature, and then the rest is fine. I have to add also another output here because I have to send the money back to the wallet. The change. Cardano. No, sorry. It should be enough to just go like cut payment test payment other. So let's do the calculation. The first thing is the fee, and the fee is this amount here. So we put the fee here. Sorry, I have to build this transaction first, otherwise this could be wrong. Perfect. Then I can calculate the fee. 689. Right, this was different. So the correct initial value is fine. And then I want to send 1,000 ADA to the wallet, and then there are the fees, so that I can calculate how much needs to be sent back into the wallet. I'll do this one, I'll get the result, and I'll put this one into this one. Now we have to find the tip. The tip, we are at this slot, and I'm gonna add about 1,000 blocks so that I am sure this should be executed. I have enough time to sign and submit the transaction. This is now built, and I have now to sign and submit. This is very simple. We have saved the previous script into txrow. What we do now, we sign txrow and we save into tx signed, and then we submit tx signed. And the transaction was submitted successfully. So you can see the transaction down here. Doesn't matter, we don't care about reading this, but now we have to wait for a block to be generated so that the funds are actually gonna get properly sent to the script. So there are still no funds here, and then as soon as a new chain extended event is raised, as soon as a new block is executed, it's added, we should be able to see our funds. There we go. I think C80 is, yeah, well, exactly 1,000 Loveless. Sorry, 1,000 Loveless is here. And this is C80 that incidentally is exactly the transaction hash datum that we've seen earlier on. So first part of the exercises is done. So basically what we've done is to take 1,000 ADA from our wallet and persist them into the smart contract. As you can see, just to recap again, these are our entries. This is the hash of our password. Here there are other people that have done exactly the same exercise. Some of them, as well as myself, I locked those 1, 2, 3, 4, 5, 6, 7, 8, 9 Lovelaces, and I forgot to put the transaction hash. Facepalm moment for me here, and then I did again the same exercise and unlocked them. So this time I'm doing live with you now, and now it's time to get those funds back. So the way we're going to be doing this is to build an every so slightly more complicated transaction. And basically this is going to still have exactly the shape of a transaction, but we're going to be having a couple of more steps. So we scroll down a little bit below. I'm going to publish all these steps into, well, actually you have them into the documentation. There is no need for me to publish these things again. But here is what I've used earlier on. And this is exactly the same because this is a new Cardano CLI transaction build. But what we have to do now is that now one of the transaction input is actually the script. Then we have another few new fields that weren't there before. So the first one is the so-called collateral. The collateral basically is a spending address that is going to be fully spent in case there is something wrong with the transaction. So there is one thing of the smart contracts is that there is an on-chain and off-chain validation. All well-written smart contracts will have an off-chain validation that will prevent the smart contracts from running if the validation will not pass. So there are some conditions that have to be met in order for the smart contract to be executed. And this is exactly what the code on-chain is doing, is validating your inputs and your outputs, and that the smart contract's conditions are actually met. But if the smart contract is wrong, or if someone is being cheeky, it is trying to interact with the smart contract, skipping the validation phase and trying to maybe get control over some funds that are locked in a contract. So what happens is that if someone like this is interacting against the smart contract, it will have to provide a collateral. If there is an issue, the money and the funds against the collateral will be withdrawn. And this is how it works. Of course, then there is the transaction out. The transaction out is where the funds will be collected and transferred. Here is like the script file. That is the one that I was showing you earlier on. And then there are a few additional information. So let's start from the execution units. So the execution units, and you can read more about this into documentation, is basically the costs that you are happy to pay for the smart contracts to run. This is a very low level details, but whenever a smart contract is executed, well, really the validation on the chain, you will have to pay for how much resources you're paying, because you have to pay an SPO, a stake pool that is, apologies, running this thing for you. And so this is how much you're happy to pay for this as fees, as additional fees for this. This is very low level. If you end up being like a higher level or just a smart contract user, you will see this as just a fraction of an ADA every time you interact with a smart contract. This will always, everything will be wrapped inside your fees, but you will not have to care about this. But two additional things that, and if you're a Plutus pioneer, you have definitely met and you remember about this, are the datum and the redeemer values. So I'll show you, those two fields in the CLI are mandatory, but in reality only one of them is actually used, and this is the datum that we had to specify at the previous step. In this case, beside the fact that the redeemer is used, is actually is required, is not actually used. So we can put whatever the hell we want in here, actually, as long as it is a number, because this has been specified as, it needs to be specified as required to be as a number, so there are no problems. And the datum here is very, very important. We have to put the actual number that we've put earlier on, otherwise at the execution time, the smart contract would say that no datum was found, and so the script will not be executed. Anyway, lots of information. Let's jump right into the execution of the smart contract. So the fees are very high. They have to be 800 ADA, and this is just part of the exercise. There are no problems whenever this goes to mainnet, and whenever the actual calculation of the fees will be implemented, because it's still ongoing, this number is going to go very small, or will be actually correctly computed and calculated. In this case, it's just going to be very, very high. And then let's just execute this exercise. The fee, I've pre-calculated them. If you put any less, it will throw you an error. I will not show this one to you. I want to try to keep this video short and sweet. So the transaction input, let's fix the transaction input. So first of all, because we have persisted the 1000 ADA, we should be able to pay the transaction straight away from the money that we collect from the script. So we will only need one input. In this case, we get this input with the transaction IX0. So we'll put this one here, and we put 0 here. Now, earlier on, when I was trying this, I didn't have enough fund locked into the script, so I needed another input. So let's simplify this a little bit, and we remove it. So we do now have the collateral, and for the collateral, what we have to do is we have to provide a wallet address. So in this case, I'm gonna get my own wallet address. So UTXO cat payment address, I'm gonna be using this one here, and then X0, PAM and 0. And then the next thing is where I want to put those funds. So what I can actually do is I can just reuse the cat test payment addr that I've been using earlier on, and then I have to calculate how much this is left. So this is how much I have to pay in fees. So I'm going to be putting a minus. This is how much is in the wallet, in the script, in the smart contract. And then I can take whatever is left, and this is actually going to go into my wallet. It's funny, like we put 1,000 ADA and we're only going to get a very small amount after, but this is part of the testing. So we can now take this bad boy here and we can build it, and we can now sign it and submit it. Transaction was accepted. You can see that 1,000 loveless are still here. In the meantime, a new tip was raised, as if you're lucky, the money have just gone. You can see that there is no C80 with 1,000 loveless anymore. It's up here, but it's not down here. And let's see if in our wallet they've arrived. And yes, I think this is the 19982. 199822135. We've collected the money back. Of course, we used the fund inside the wallet, inside the smart contract, to pay for the transaction, and whatever was left went into our wallet. So there you go. Exercises of week 3 are done. Sorry, not week 3, of the third exercise of Alonzo Blue are done. So I can move to the next one. There are some interesting questions around here. We have already found out that the redeemer it can be anything. It didn't need to be the same as the datum, and that's absolutely fine, because redeemer and datum, they are two different fields within the validation script. It only makes sense to have one, doesn't make sense to have two, and in this case they decided to use the datum as a parameter. I think it would have worked the same for redeemer, even though, yes, I think, no, sorry, I think datum in this case makes more sense, because this is an information needs to be persistent inside the UTXO. So that's absolutely correct. And this is pretty much it. Another thing was try to steal the money from other thing, but like we need this for loop to run for a little bit of someone else datum. There is a long for loop, and it's gonna take hours. Anyway, feel free to please like and subscribe to the channel. I remind you that I'm stake pool operator of the stake pool Easy One. Please, if you like the content of my video, delegate to my stake pool. We've reached 2 million and we are minting blocks every single epoch. But we need the pool to grow a little bit more. Yeah, thank you very much. Let me know if you have questions. Subscribe to the channel. Reach out to me on Twitter as well. My handle is CryptoJoe11. I'll definitely add into the description and also into the video, so that if you're interested and want to reach out to me, you can find how to do that. Thank you very much, and I'll see you next time. Bye. Thank you.